Okay, so now let's talking about some partition problem. So partition problem means we split all into parts. Like suppose here we have many, so we just split into this part, like how many ways, just like that. So we call such a problem partition. So for this problem, this is Jim has 9 different toys. He wants to split them into 3 parts. So each has 3 toys. Then put the toys into 3 different boxes. So how many ways? So we have 9 toys. Okay, we have those A, B, C, D. Suppose A, B, C, D. Okay, we have 9. Okay, so we have 3 boxes. We want to put them to box A, this box, B, box C. Okay. So here we just from 9. So we just pick 3, put 3 here, put 3 here, put 3 here. Right. So put 3 toys. We just pick 3 toys and put them to box A. So how many ways? We have from 9. We just pick 3, right? Okay. So put it to A. Then by now we have 6 toys, right? So from the 6, we just pick 3, put the 3 to box B. And now we have 3 toys left. So we put this 3 into box C. So choose from 3, we choose 3. So this is how many ways? Number of ways. Okay. So this problem is we can regard it. We can say put 9 objects, 9 different things into 3 boxes, 3 different boxes. So now let's consider this problem. We want to put this 9 different toys into 3 parts. We just split them into these 3 parts. So each has 3. Okay, so 3 parts and put this into 3 boxes, 3 different boxes. So they have those these 2 questions are different. So here we just put this 3, like here just this. Let's say suppose this is 1, 2, 3. Okay, so 4, 5, 6, and let's say 7, 8, 9. Okay. So this way and this way, let's say this is like so here we just put this, split the 9 into 3 parts. Okay, so at first we just pick like 7, 8, 9, put them together. Okay, and 1, 2, 3 together as the parts. So those 2 things are same. Okay, so now suppose suppose we say if we consider the position, let's say box. Suppose this is box A. Suppose we just consider box A, box B, box C. if we consider 3 different boxes, then there's 2 ways for separations are different, right? So we know, so put 9 different toys into 3 different boxes. We know this way is from 9 choose 3, put to box A, then remaining one 6, choose 6, from 6 choose 3, put the box B, and then from remaining 3 choose 3, put the box C. So here we do not consider boxes. Okay, so we say those things are same. So we can say like if we have these 3, we already separated into these 3 parts. If we already consider these 3 parts, then if we consider this, we have these 3 parts, then we chaining these 3 positions. If we chaining these to here, chaining these to here, we regard those are the same. So let's say, chaining, like chaining 3 box, chaining this like ABC, chaining this 3 box, A can here, like chaining this 3 box. How many ways? So chaining 3 box, we have so many ways, just 3 factorial, right? So ABC, BAC, we all regard those as the same. So we should divide by this. Divide by, there's 6 cases actually. There's 6 cases that we should regard the same. Okay? Okay. So here is a little bit confused. Okay, so now let's consider this problem, number of integer solutions. So for this problem, x1 plus x2 equals 6, and each x1, x2, each one is larger than 1. So how many integer solutions? So for this problem, we can list all solutions, like can be x1, x2. Okay, so x1 can be 1. Then if x1 1, then x2 is 5. 1, 5. Or x1 can be 2, then 4, right? Or 3, 3, 4, 2, 5, 1. So how many integer solutions? We say 5, right? We have 5 solutions. So here we just list all cases. Okay. So let's say for this problem, how many integer solutions? So we also can use this way. We just list all solutions, like x1, x2, x3. So we just start from smallest one. x1 is 1, x2 1, then this is 4, right? So x1, so x2 become 2, so this is 3, right? Okay, so yeah, so how about 1, 3, so 2, yeah, so 1, 4, if this x2 equal 4, then 1. Okay, so this is x1 equal 1, then x1 equal 2. So we just x1 equal 2, then x2, so can be 1, 3, right? So we can use this way, we can list all the cases. But we say this is not a good way because we have too many cases. So here we try find a better way, a good way to solve such a problem. Okay, so we regard such a problem as like that. We have we have 6 bars like 1, 1, 1, 1, 1, 1. We have 6 bars. We want to split 6 bars into 3 parts. So could be like this, or could be, let's say, split them into 3 parts, or could be this. So this one related to this solution, x1 is 2, then 3, 1, right? 2, 3, 1. So this one, what is the point of this solution? X1 equal 1, 3, 1, 3, 2, right? Okay. So such a problem become like we have 6 bars. We want to split them into 3 parts. So how to split them? So we just let's say we just put these 2 bars like this one or this one, right? We just use the 2 bars to split. Okay. So where we can put these 2 bars? So we can put 2 bars. This position here, 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 right? So this one we can put a bar here, okay? We can put a bar, maybe put a bar here. Let's see. Okay, we just use this. Let's say we have 5 bars, no 5 bars, no 6 bars. Okay, and we want to split. So let's say we can put bars this position. Let's say we can put let's say into this positions. Okay, yeah, we can put a bar here, here, or here, or here. We cannot put a bar here, right? If you put a bar here, then this solution x3 is 0. So cannot be. So we have 5 positions. So from 5 positions, we just pick 2 positions. For these 2 positions, we put those big bars to split them, right? So how many ways? We say from 5, we just pick 2. So we have so many solutions. Okay, so now let's go back to this problem, like this easy problem, right? X1 plus x2 equals 6. So we have 6 bars. Okay, we have 6 bars, and we want to split into 2 parts. So this means we just need 1 bar, one to split them. Okay, so we can put position here, 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 right? So from this 5 position, we just pick 1 position. We can put a splitting bar there. We can split it, right? So how many ways? We say from 5 position, we just pick 1. Suppose like we pick this one. Okay, so pick this one. So we get a solution 2, 4, right? So this equals 5. So this equals this, right? Okay, so we can use this way to find number of integer solutions. Okay, so now there's a problem. So by now there's a problem is become easy one. So we have 15. We have 15. Let's say 15 bars, like, and we want to split. We have x1, x. We have wanted to split it into 4 parts. So we just need 3 of them, right? We just need 3 of them. So we can split this into 4 parts. Okay, so how many positions? So actually we can find, if there's 15, then we have 14 positions. So from the 14 positions, we just choose 3 positions to put the splitting bars, right? Okay. Okay, so now let's consider the problem. 3 friends have a total of 6 identical pencil, and each one has at least 1 pencil. So how many ways? So this is such a problem. We can regard this as equation problem. Like, so 3 friends, 3 people. So first one we have x1 pencil and x2 pencil, x3 pencil. Like first one has x1 pencil, second friend has x2 pencil. So we have this equation equals 6, right? And each one at least has 1 pencil. This means xi, x1, x2 each one should be at least equal 1. So how many ways? So this means like we have 6 pencils, 6 bars. We want to split them into 3 parts. So we should choose two positions to split them. So how many positions we can choose? 1, 2, 3, 4, 5. So that's equal from 5 choose 2, right? So this is how many ways. This equal 5 choose 2 is multiply 2 numbers. Start from 5 here, multiply 2 numbers, start from 1. So 1 times 2, so that's equal 10. Okay. So here, those problems, the number of triangles can be formed from some points. Like from 10 points, how many triangle can be formed? Okay, so we say, let's say, if we have the 4 points, then how many triangle? We just pick a triangle. We just pick 3 points, make a triangle, right? So can be this triangle, or if we pick this 3, we can make this triangle, right? So if we pick this 3, then we can have this triangle. So how many triangles? So we say from 10 points, just pick 3. So we have so many. Okay. So these points, no 3. So here we condition no 3 on the same line. Like if like these, let's say these 3 points cannot make a triangle, right? But these three, if there's a point here, then we can make a triangle, right? Okay. So here we have 6 points. Yeah, 6 points. So pick 3 to form a triangle. So how many? How many triangles? So such a problem, it seems so easy, like, oh, from 6 choose 3. But many, so but some triangles are the same. So here we have this condition: non-congruent, not the same. Like with same, if there's 2 triangles exactly the same, so we cannot count them twice. Okay, so for such a problem, so we cannot use this. So we just check. Okay, so let's say we just check it. Okay, here. 1 1. Okay, 1 2 1 3. Oh, so 2 1 2 2 2 3. Oh, this is 6 points. So we also can use this way. We have these 6 points. How many different triangle, basically different triangles can be formed. So let's say if this side is 1, we say if this is 1, then so if we choose these 2 points, then we can pick this one, and this one, right? So it seems like we have the 3, right? So those 3 triangle not the same, so we have 3. But for these 2, if we pick these 2, so we also can make this 3, right? But this 3 and those 3 are same, so we just say we just have 3. If one side is this side is 1, then we have 3 triangles, like this one, right? And yeah, and this. Oh, I'm sorry, only 2, not 3. These 2 triangles are same, right? Yeah. So such a problem is type 2. Only let's say only this one and this one. We have only 2 different triangles. Yeah. Okay, so then if we pick these 2, okay, maybe I put it here. If we pick these 2, like we pick these 2, then here we have also from, so we can pick, we have 3 points we can pick. Pick this one is okay. Pick this one is okay. Pick this one is okay. But again, like these 2 triangles same, so we cannot count them twice. So if there's 2, we still has only 2 of them, right? 2. So totally we can have 2 plus 2. We can only make 4 different triangles. 2 different triangles. Not 2, 4 different. Yeah, 4. Yeah. Okay. So such a problem, we should be careful. Yeah. No, so, okay. So we have a similar problem, like let's say from this 5 vertex of a pentagon. pick 3 points to form triangle. How many different triangles? So this regular, let's say this pentagon is, we can see this regular pentagon, should be regular pentagon. Okay, so now if we pick these 2 points, so how many triangles? We can pick E, we can pick A, we can pick B, but E and B is the same. So we just have, let's say, we just have 2 of them, right? And so if we check BC or DC, check BC, same. So we can regard, we just check one side is only 1. Then we check, let's say, BD. So BD, we check E, we can pick E like a BDE or B, like a DBE or DBA. But the DBE, DBA is the same. So here we just have only 1. And if we check a DA, if we pick a DA, this one, if we pick a, I'm sorry, there's a problem, we should be careful. Like, if we pick a DB, then we can pick E as a point, E, A, or C. So E, A, let's say, we say triangle DBE and triangle DBA. Those are same. But we also can use triangle DBC. So DBC, DBE, not the same. So this also should be +1, right? So, yeah, 2. Okay, so totally we have 4. Okay, let's say like here we have 2, yeah, and this we have 2, yeah. Okay. Okay. So here we have 8 points. 8 points, but there's, so 8 points, this thing same. Now there's 4 points, and there's 4 points. So here's how many cells. So we just check, like, if we choose these 2 points, saying the same as we can, from these 4 we can pick any of them. So the same as we have 4, but let's say choose these 2 same, right? Yeah, so we should -1, so equals 3. Okay, then we just check, okay, how about we just check these 2. Okay, there's 2. Check these 2. So, and again, like here we have 4. We can, from this 4, just pick 1. So pick this one and this one the same, and pick this one. So pick this one. So we have 3, right? Yeah. Pick this one, 1, 2, but this one, okay, same, right? Okay. Okay, so now then, if we pick this 2, or this length is 3, pick this 2. Then again, like here we have 4 points. We can pick any one. So it seems we have 4, but pick this one and this one same, right? This triangle and this triangle same, and then this one and this one also same, right? So we have only 2. So totally we have only 8. Okay. Okay. So for such a problem, no good way, but we just check one by one. Just check how about this side length is 1. Okay, this case then 2, then this is 3, right? So if we check check this one, maybe forget like this. Oh, I'm sorry. This and this same. Alright, if we pick this 2 and pick this 2 same, and how about pick this 2? Pick this 2. The answer may be not correct. Maybe we should pick this 2. Like let's say. So we need to be really careful with the same. If we pick this 2, then we have this one, this one, this one. So we have so those are the same. So we have the 2, but this one we already count, and this one 1 for this one. I think this one also counted. This one equals this one. Yeah. Okay. So we don't need to check this. Okay. Okay. The answer is 8, I think. Okay. So we stop here.